if I told you that right now, in some hospitals, doctors still use leeches to treat patients? Yes, those slimy, blood-sucking creatures. But here's something even more mind-blowing. Leech bacteria have become resistant to antibiotics, turning this ancient practice into a modern dilemma. While antibiotics were once seen as miracle drugs, today, superbugs are outsmarting them. From bizarre leech therapies to the rise of antibiotic resistance, infection treatments are taking some wild turns. Ready to explore this crazy evolution? Number 1. Leeches and ancient medicine. Leeches were once the go-to treatment for infections and other illnesses. It may sound odd now, but back in ancient Egypt and Greece, people believed that bloodletting, using leeches to suck out bad blood, could cure everything from headaches to fevers. The idea was to restore balance in the body's fluids, which was thought to be the cause of illnesses. This was the best medical knowledge they had at the time, and surprisingly, it was used for thousands of years. Today, leeches are still used in some specialized areas of medicine. For example, in surgeries where blood flow needs to be restored, like reattaching a finger, doctors use leeches to improve circulation. It's fascinating that these little creatures are still helpful in certain medical situations, showing us that some ancient treatments still have a place in modern medicine. Number 2. The accidental discovery of antibiotics. Did you know that antibiotics were discovered by accident? Sir Alexander Fleming stumbled upon penicillin in 1928 when he noticed that a mold was killing the bacteria he was studying. This unexpected find changed the world. Before antibiotics, simple infections could be fatal. Imagine getting a scratch on your hand and having no way to stop the infection from spreading. Antibiotics revolutionized medicine, making it possible to treat infections quickly and safely. But here's where things get tricky. Antibiotics were once seen as the ultimate weapon against infections, but bacteria have been fighting back. Over time, some bacteria have developed resistance to antibiotics, meaning these once powerful drugs don't always work as well. This is where our modern battle with superbugs begins. We have to be smarter about how we use antibiotics, or else these resistant bacteria will continue to spread. Number 3. How antibiotic resistance happens. So how do bacteria become resistant to antibiotics? It's all about evolution. When bacteria are exposed to antibiotics, most of them die off. But every now and then, one might have a random mutation that allows it to survive. This bacteria then multiplies, creating more resistant bacteria. Over time, the resistant bacteria take over, and the antibiotics that used to work stop being effective. The scary part is that bacteria can share their resistance with other bacteria. They can transfer their genes, making other bacteria resistant too. This is why superbugs, like MRSA or methicillin-resistant Staphylococcus aureus, have become such a problem in hospitals. These bacteria are tough to kill and can cause serious infections. It's a reminder that we need to be careful about using antibiotics only when necessary. Number 4. Phage therapy, an old solution to a new problem. While antibiotics have been the standard for treating infections, another solution has been around for a long time: phage therapy. Phages are viruses that infect and kill bacteria. They're like nature's own antibiotic. Phage therapy was used in the early 20th century but fell out of favor when antibiotics were discovered. Now, with the rise of antibiotic-resistant bacteria, scientists are taking another look at phage therapy as a possible solution. Phage therapy works differently than antibiotics. While antibiotics target and destroy a wide range of bacteria, both good and bad, phages are much more specific. They only attack the bacteria they're designed for, leaving the rest of the body's bacteria alone. This makes them a more targeted and potentially safer option for treating infections in the future. Number 5. Bacteria in leeches and antibiotic resistance. Here's an interesting twist. Leeches themselves have bacteria in their guts that help them digest blood. However, when scientists tried using antibiotics on patients undergoing leech therapy, they found that the bacteria in the leech's guts have developed resistance to those antibiotics. Even small amounts of antibiotics can cause this resistance, which means we have to be cautious about how antibiotics are used in the environment. This resistance in leeches highlights a much bigger problem. Antibiotics can leak into our environment from farms, hospitals, and pharmaceutical plants, creating the perfect conditions for bacteria to evolve and become resistant. It's a reminder that antibiotic resistance isn't just a problem in hospitals. It's a global issue that affects everyone. Number 6. Antibiotics in our food chain. Did you know that antibiotics are often used in agriculture, especially in raising livestock? Farmers give animals antibiotics to prevent disease and help them grow faster. But this widespread use of antibiotics in animals has contributed to the rise of antibiotic-resistant bacteria. These bacteria can then make their way into the food we eat, potentially causing health problems in humans. The good news is that there's been a push to reduce the use of antibiotics in agriculture. Many countries are starting to regulate and limit how antibiotics can be used in farming, which helps reduce the spread of resistant bacteria. It's a small step, but it's crucial in the fight against antibiotic resistance. Number 7. The rise of superbugs. Superbugs are bacteria that have become resistant to multiple antibiotics, and they're a growing threat worldwide. Infections that were once easily treated with antibiotics are becoming harder to treat. One of the most well-known superbugs is MRSA, which can cause skin infections, pneumonia, and even sepsis. It's resistant to many antibiotics, making it dangerous, especially in hospitals. The rise of superbugs is a reminder that we can't rely on antibiotics alone to treat infections. We need to find new ways to prevent and treat infections before they become life-threatening. This includes better hygiene practices, developing new antibiotics, and exploring alternative treatments like phage therapy. Number 8. Manuka honey, nature's antibiotic. Here's a sweet secret. Honey, especially Manuka honey, has natural antibacterial properties. It's been used for centuries to treat wounds and infections. Manuka honey in particular contains a compound called methylglycol, which can kill bacteria. What's interesting is that there's no evidence that bacteria can become resistant to honey, making it a potential alternative to antibiotics in some cases. Manuka honey has been shown to be effective against antibiotic-resistant bacteria like MRSA. It's being used in hospitals as a natural treatment for wounds, and research into its potential as a broader treatment is ongoing. It's another example of how ancient remedies are making a comeback in modern medicine. Number 9. The role of vaccines in infection prevention. While antibiotics treat infections, vaccines help prevent them. Vaccines work by stimulating the body's immune system to recognize and fight specific bacteria or viruses. In the context of antibiotic resistance, vaccines play a critical role because they can reduce the need for antibiotics in the first place. For example, vaccines for pneumonia or meningitis can prevent serious bacterial infections that would otherwise require antibiotics. The development of more vaccines could be key in the fight against antibiotic resistance. By preventing infections from happening in the first place, we reduce the chance of bacteria becoming resistant to antibiotics. It's a preventative approach that can make a huge difference in the long run. Number 10. The future of infection treatments. Looking ahead, it's clear that the future of infection treatment won't rely solely on antibiotics. We're seeing a growing interest in alternative treatments like phage therapy, medicinal honey, and vaccines. Scientists are also working on developing new antibiotics that bacteria haven't yet become resistant to, but it's a race against time. The key takeaway here is that we need a multifaceted approach to infection treatment. Antibiotics will always have a place, but we also need to explore other options and use antibiotics responsibly to slow the spread of resistance. The future of medicine might look very different from what we're used to, but with new tools and strategies, we can stay ahead of the ever-evolving world of bacteria. And there you have it. From leeches to antibiotics and beyond, the battle against infections is constantly evolving. The question is, will we keep up with the bacteria? Stay tuned for more surprising medical twists.